Conditional and biconditional. Both of them have the word if. Conditional, the conditional form is if P then Q. The biconditional form is P if and only if Q. The symbols for the conditional are P implies Q, and for biconditional, P implies Q and Q implies P. These are truth tables for the conditional and the biconditional. So notice the P and the Q columns are the same. Those never change. Now you input them into the conditional and input the P and the Q to the biconditional. So what this one's saying is, if you look at all of these, the only one that's false is the one where you have P true and Q false. That's the only time the conditional is false, when the P is true and the Q is false. The biconditional, it's true only if both are true, or it's true when both are false. So for the biconditional, if the P and the Q are the same, the result is true. Any other time, it's false. There are three related statements for P implies Q, or if P, then Q. So this is the given. We start off with the given. The converse, what you do is you reverse. The Q takes the place of the P, and the P takes the place of the Q. You could remember the converse by thinking reverse. For the inverse, you could remember the inverse. Notice it looks like the given, but you're going to insert a negation. So inverse, think of insert negation. The contrapositive form, the way you remember this, is that you do both. You reverse and insert. So notice I reverse the given logic variables. I switched them around, and I also inserted a negation. So for the contrapositive, you reverse and insert. Here's an example. If I'm in San Francisco, then I'm in California. I am in San Francisco. Whatever comes after the if is going to be the P. Whatever comes after the then is going to be the Q. So following the previous slide, the converse of the given statement, you reverse the P and the Q. So notice where California was the second thing we said, now it's the first. San Francisco part was the first, now it's the second. You reverse the P and the Q. For the inverse, leave it as the given, but just insert not. So the given had San Francisco first and California second, but now it has a not in front of it. If I am not in San Francisco, then I am not in California. And for the contrapositive, remember you switch it around and insert. So you switch it around, the given, switch it around and insert. So San Francisco and California switch. And on top of that, we insert a not. Another way of testing or determining valid reasoning is to use Euler diagrams. What do you look out for in an Euler diagram? Well, you're going to be drawing circles, and you're going to label the circles depending on what your statements are, your hypothesis is. And then the circles are either going to overlap or not overlap. So draw the circles so they describe the hypothesis. Notice, you're going to do the circles for the hypothesis. You don't draw circles for the conclusion. The conclusion should automatically follow the hypothesis circle if the argument is in fact true, is in fact valid. Hypothesis, for example, all elementary school teachers are mathematically literate. Draw a circle for that. So all elementary school teachers are within the mathematical literate circle. Continue with the hypothesis. Some mathematical literate people are not children. So they're talking about children. That's another circle. So now that you have these circles, they describe the hypothesis. All elementary school teachers are mathematically literate, so they're all within that M circle. Some mathematically literate people, so some people in the M circle are not children. And as you see, actually all of them are not children. Now let the C circle overlap with the M circle and see the hypothesis is being described. All elementary school teachers are mathematically literate, okay? Some mathematically literate people are not children. So the one that's here, this is the person that's mathematically literate and is a child, but there are some, which are the ones outside, out here, that are not children. So I still have the hypothesis being described. Then this one, notice how the circles describe the hypothesis. All elementary school teachers are mathematically literate. Some mathematically literate people are not children, so that would be the ones out here are not children. But look at what happens. In both of these, the conclusion was already implied. No elementary school teacher is a child. Notice the child circles not intersect the elementary school teacher, so the conclusion is valid. But when you get to this, you find a counterexample. This is the exception to the rule. This one is saying that the hypothesis is true, but the conclusion is not, because the conclusion should have been no elementary school teacher is a child. But right here we found one that's an elementary school teacher and is a child. So since we found one exception, one counterexample, this argument is not valid. This next one talks about how to demonstrate an argument is valid. That's another way. These are forms. If you could get your arguments and your conclusions to fall into one of these forms, then your argument is going to be valid. So this one, if P equals Q, and then P is true, therefore Q is true. If you could follow this form, put your argument in this form, it's going to be valid. And notice you could remember, because this P is pointing to this Q, just imagine you put an arrow here and it's going to look exactly like this one. That's one way of remembering the form. That's a valid form for a valid argument. This is another form that tells you if the argument is valid. In this case, look how the P is pointing to the Q. And if you would have put an arrow here, that would be the contrapositive. And we said that the condition of the given statement and the contrapositive are equivalent. So I generate the contrapositive here. That's one way to remember that what this form looks like for a valid argument. This one, I'm going from P to Q and then Q to R. It's transitive. It's transitive. For P to Q, and then I go Q to R. That means I could go from P to R. It's like the bus taking you to different places, so it took you from the first place to the last place. If it's in this form, your argument, it's valid. This was direct reasoning form, indirect reasoning form, and transitivity reasoning form.